Good afternoon. My name is Carrie Starnes and I'm going to be doing my science experiment today, Fizzy rockets. The question for my experiment is which solid and liquid combination causes the most gas to be produced, resulting in the greatest liftoff of the rocket into the air for the longest amount of time. The hypothesis I've chosen is the combination of antacid tablets and vinegar will produce the most gases to cause the rocket to fly the longest. The two standards I've chosen for my experiment are SC.2.P.8.2. Identify objects and materials as solid, liquid, or gases. For my experiment, I've chosen 3 different solids and 3 different liquids. The other standard I've used is SC.2.P.13.4. Demonstrate the greater the force, push or pull applied to an object, the greater the change in motion of the object.
Press it.
Okay, the first rocket we're doing is the red rocket, which is we're going to use 2 anti-acid tablets and 40 milliliters of vinegar. Okay, Hayden. Goes in. Okay, pour the vinegar. Give me the lid. Pour it quickly. Okay, put the lid. Okay, set it down.
Whoa.
Oh, well.
Do it.
Okay, we're going to try this again with only now using 20 milliliters of vinegar. Go ahead and pour it in. With 1 anti-acid tablet. Go ahead and put it in. Put the cap on.
That didn't even work.
I don't think the cap was on there hard enough. Dang it.
Ain't gonna work. Do it.
Okay, the third time. Now we're going to use 20 milliliters of vinegar to a half tablet of the anti-acid. Okay. Get the cap in your hand. Okay. Hurry up, quickly. Now, get ready. Okay. Well, at least that one did a little better this time. And as I was timing it, cannot see it on the stopwatch here, the liftoff was 3 seconds and the time in flight was 1 second. Okay, I'm going to fill the information out on the Fizzy data launch data sheet. And on this one, I'm just going to make a note down here, was a half a tablet to 20 mils of the vinegar. Okay, the launch time was 3 seconds. And the flight time was 1 second. Okay, now our second experiment is going to be our yellow rocket, which is going to be 20 mils of seltzer water to 1 package of Pop Rocks. Do not put. Okay, we're going to try the yellow rocket again, this time with 40 mLs of seltzer water with a package of Pop Rocks. Go ahead.
What? It won't.
Okay. Hurry up, Hayden.
I can't. I don't know if I got it.
Okay, set it down.
That one's going to explode. It's just for a week.
Okay, this one we have another one that's leaking out. Okay, this is trial 3 for the yellow rocket. And this time we're going to use the pop rocks, and we're using 60 ml of seltzer. This time we're going to pour the pop rocks in first. Pour the seltzer water in. Hurry. Okay, that was a little bit better. The launch was 2 seconds, and the time in flight was another second.
Okay,
So the launch time was 2 seconds, and the flight time was a second. And then I'm also going to make a notation. We use 60 ml of the seltzer water. And 1 package of Pop Rocks.
Ow, that hurt.
Okay, now we have our liftoff rocket number 3, the orange rocket, which is going to be 1 tablespoon of baking soda with 40 ml of Diet Coke. Okay, this is trial number 3, and this time we're going to use 2 tablespoons of baking soda, which is we've already put 1 tablespoon inside the rocket, and we got 60 ml of the Diet Coke. And we're going to shake it just a little bit to make sure everything's mixed. And we had a little too much. Okay, this is trial number 3 with the orange rocket. And we've gone back to the 40 ml of the Diet Coke that we're going to put in first this time. Okay, and now we've gone back to the 1 tablespoon of baking soda.
Shake?
Yeah, a little bit. Okay, turn it down. Okay, put it down.
That ain't gonna do nothing. It's just flicking under the bottom. Let's try the Coke.
Okay, on the orange rocket, we're going to put 0 time for the launch and 0 for flight. And then we're going to make a notation of what we did on the first. We used the 20 ml and the 1 table.
It's running.
Yeah, I know, feel it. Then we did 40 mLs to 2. And then we went back to 40 mLs with 1 table. So the longest in flight, which it was a tie between the antacid, tablet and vinegar, and the pop rock and seltzer, between the yellow and the red rocket, and the orange. So the conclusion of this experiment was that my hypothesis was partially correct, that even though it was the antacid, tablets, and vinegar was not the longest in flight, it did tie with the pop rock candy and the seltzer water. So, in conclusion with my experiment, different launch times and flight times can be concluded that the different amounts is what changes the launch times and the flight times of it. And this experiment can be used for different varieties. Even everything could be interchanged. You could do the antacids with the seltzer water, or with the Diet Coke, or different pop rocks, and all this. And one thing that was nice about this experiment, it was very inexpensive. Even though my vinegar bottle says Publix, the vinegar bottle in the back and all these items, besides the Arm & Hammer baking soda, came from the Dollar Tree, or you could buy it inexpensively at Walmart. For my whole experiment, I spent roughly less than $10 on everything I did. But you could use you can use lemon juice as another liquid. You can use Mentos for another solid. But this gives an idea of the different changes between the solids and liquids that can produce gases of carbon dioxide and can propel a canister rocket into the air. Thank you for your time.